So the first step in kind of getting comfortable with this new imaginary number of ours, and more generally complex numbers, is figuring out how to simplify expressions that have a negative number under a square root, right? Because that's something we weren't able to do before. Okay, so I've got some examples here for us to look at, and I've got our two definitions up at the top. I squared equals -1 is actually the technical definition, but that's really equivalent to I equals the square root of -1, and that's the one that we're mostly going to be using here in this lecture. So let's look at the square root of -2, right? I'm going to split this up, right, because we could do this with square roots. I'm going to make this the square root of -1 times 2. I'm going to split it up again, just using all the same principles of simplifying square roots we've used before, right? Square root of -1 times the square root of 2. And the square root of -1, that's our new imaginary number I. So square root of -2 simplifies to I times the square root of -2. Okay, so let's try this again on the middle one here, the square root of -16. Now you notice, I'm sure right away, right, 16 is a perfect square. So we're going to treat this exactly the same way. I'm going to split it up, square root of -1, square root of 16. Square root of -1, that's I. Square root of 16, of course, is 4, right? So the square root of -16 simplifies to 4I. You notice how I wrote this here, right? I did put the I second. I don't want to give you the impression that I is a variable, because it isn't. I is a number. But in some ways, you'll see this some more in the next lecture where we talk about doing arithmetic with these complex numbers, we do kind of structurally treat it like one, right? Like here, if that had been an x, it would have gone at the end, right? The number will go first and the x will go second. We treat this exactly the same way. Okay, so how about square root of -75? Well, I'm going to split this into 3 parts. -125 and 3. Square root of -1 is I. Square root of 25 is 5. So this becomes 5I times the square root of 3. Now, obviously, we're new to this, right? I'm writing this out in a fairly low level of detail so you can see all the steps. As you get used to this, I mean, if I see something like the square root of -2, I just immediately think, okay, that negative sign comes out and becomes an I, and the 2 is left behind. And I'm not going to write out all of this level of detail every single time I want to simplify a single expression. Okay, now we do have one weird situation we have to deal with. Let's say I wanted to simplify this. There's 2 different ways we could approach this. One way would be to say this is I times the square root of 3 times I times the square root of 2. Right? I did what I said on the last slide, right? I pulled the -1 out and made it an I. But now look at what happens here. I times I is I squared. Square root of 3 times square root of 2 is square root of 6. And now look back at that definition again, right? Our definition says I squared is -1. So I can simplify this further to negative square root of 6. Okay, that's one way to do this. There's another way. Right? Another way, I could just combine the 2 square roots together. Square root of -3 times -2, which is the square root of 6. A very different answer. Only one of these can be right. We can't have an expression simplify to obviously very different numbers. Okay? The way on the left is the correct approach. Right? When you're going to square root, and I don't know the history behind this, but if I had to just kind of make a guess, I would say, look, you can't take the square root of a negative number and have it come out to a real number. Right? You have to invoke our new imaginary number. Doing the right-hand way makes it look like it's somehow the same as the square root of +3 times the square root of +2, and it's not. Doing it the other way clearly makes this into something different, which I think, to me anyway, is kind of a motivator for choosing that option over the other one. Okay, so now we're hopefully squared away on simplifying square roots of negative numbers, which we couldn't even do, before we had this new definition. So in the next lecture, we're going to take a look at how to do arithmetic with complex numbers. If we're going to treat these complex numbers as the solutions to equations, we have to be able to check them. Right? We have to be able to substitute them back into the equation and confirm for ourselves that they work, which means we need to be able to do all the same arithmetic operations, addition, subtraction, multiplication, exponents, with these complex numbers that we could do with regular real numbers. So that's what we're going to start working through in the next lecture.